Hi, this is Greg Koopman. Today I'm going to talk to you about SSIS Transactional Processing Options and the one that is my favorite. Why and when do you really need transactional processing? Okay, in a data warehouse situation. Well, in your extract phase, generally you probably don't need to have transactional processing turned on. The reason being is because in most extract phases of the data warehouse, ETL, that you do a truncate table and then you insert during each period. So in other words, every day when you go and do your extract and loads, in your extracts you're gonna have a set of staging tables that you truncate, and then you just load for that particular day or that particular day's data. And that's really all it is. So if there's an error or something happens, you can always just truncate and reload it. Now, when you load your ODS loads from your extract, from your staging tables, generally, let's say for example you're going back 10 days, because there's corrections always being made, and so it's really not ever just exactly right. So there could be a correction that was made 5 days ago, or a few of them, or a lot of them. So anyways, most people have a window of, like, let's say 3 to 10 days that they find they have to go back. So what they do is they go back and they delete from the ODS tables 3 days back, then they reload 3 days forward from their extract tables. So that's a typical scenario. Now during that time, if you delete, for example, let's say for example you go 10 days back and you delete, and you find out, there's only 3 days that was given to us, and now we can't get those other 10 days. That's a problem. So you might put some transactional processing on that, so that if there's an error such as that, you could do a rollback and it will come back to the way it was right before until you sort out the problem. The next one is when you go from your ODS database to your EDW, your Enterprise Data Warehouse database. And in that case, if you have changing dimensions type 2 especially, those require updates. And so when you do an update, in place update, those you might lose the day before, depending on the situation. In general, if you were doing this every day, you get a new set of data, and it's for that new day, you wouldn't be a problem. But because of this concept of having to go 3 to 10 days back for corrections, when you do those updates, you could actually be losing some information that you sense of a transactional set of data, and you're not able to recover from it and start over from where you left off. These transactional processing is just so that you can get back up to speed right away. So that's with the loading the EDW, and when you're doing updating, changing dimensions in the scenario I just spoke of, that could be another situation where it'd be very convenient and very efficient to keep a transaction going as you go through updating those rows. The same thing goes with updates and deletes in other situations, maybe not even a data warehouse. For example, your typical banking model where you're withdrawing data, where someone cashes a check and deposit the money in one account, withdraw it from another account. That's a whole transaction. It might be hitting several tables to do that, and that you want to definitely have within a transaction, so if something breaks in the middle, you don't get stuck with inconsistent data. So there are times in a data warehouse that you want to have transactions ready to go. Again, not so much in the extract phase, but in downstream type processes, it will come in more handy. Okay, and again, the last thing is, no matter what you do with transactions, they are never ever a replacement for database backups. So always make sure you have your backups, okay, so you can restore from there if everything else goes haywire, okay, to a consistent state. Let me also state that in your ETL, anything you can do where you don't have to use transactions, that's a good thing. And so if you can organize your process and your logic and your restartability of your packages and your ETL without having to use transactions, that's the best place you can be. But there's just some places where you'll know them when you see them usually, that you're going to need some transaction processing, and you're going to need to wrap your code into some transaction. Okay, I'm going to first discuss in brief different options, and this is not all the options you have. There's always more, but some general options that you can use for transaction processing. But the last one I'll cover is the one that's my favorite and the one that I like to use. And we will actually have an example of that at the end of this lesson. Data recovery options in SSIS. Microsoft Distributed Transaction Coordinator, MSDTC, Snapshot Backup, Database Recovery Model Full, Metadata Process ID Status Flag, Change Data Capture, SQL task calling one top-level transaction ready stored procedure, and my favorite, embedding SQL tasks loaded with TSQL transaction code around the control flow tasks. Microsoft Distributed Transaction Coordinator. Okay, this goes with SSIS. It's kind of built in, but it's not built in. You have to activate this service before you can use it with SSIS. But SSIS has properties amongst its objects, including the package that is a property called transaction option. And in there you can set it as supported or required and these kind of things. But I have never used it because I just didn't want to set up another service if I could help it and have to track something I really wasn't as familiar with and maybe get network people involved and all that. And I had no real need to do it that way. So I had never really used Microsoft Distributed Transaction Services. But it is a part of SSIS. It is Microsoft. It works across different servers and databases. And so it's pretty powerful, I suppose. And you can go, it seems like you can go across different technologies and servers. So that's a big deal, and that's why it's distributed. Drawbacks, it's another technology that I have to learn. It's another service to coordinate. And I think it's overkill for the kinds of work I do, which is basically if I am working with other types of technologies, I usually they're usually brought into SQL Server. Then once they're in SQL Server, I'm working on one server and a couple databases. So this is really overkill for what I need. Okay, the Snapshot Backup is a technology, and the word snapshot at Microsoft is used like 10 different times in 10 different ways and 10 different technologies of SQL Server. But the Snapshot Backup is I haven't seen it used too many places. I love to use it myself. Let me give you the benefits. It's very easy to implement. You can view and access the data the way it was at the beginning of the ETL process. It's available in Enterprise SQL Server since 2008. It's available in Standard SQL Server Edition since 2016 SP1. Drawbacks. When you do a restore of a snapshot, it's going to restore everything. So let's say someone else is running some process in the same database at the same time. Well, you're going to overwrite their stuff. So if you don't have anything else for being written to, and you're in control of that database and that scheduling time zone, then you can restore it and it won't be a problem. Drawback, again, does not automatically roll back. So if you're going to roll it back, you'll probably have to write a piece of code that just does restore from snapshot, and it will restore it back to that point in time when you first made it, which is exactly at the point in time when you start your ETL process, or that part of the ETL process that you want to set for recovery. And then the last thing is you need to remove these snapshots because they take up space on your hard drive as files when they're no longer needed. So if you're doing them every day, doing one a day, or maybe you're doing more than one a day, you probably have to get rid of those eventually. Now, just to say one more thing about this, how it works. When you do a snapshot, when you create a snapshot of your database, it makes that point-in-time snapshot available to you as a separate database. So this is great for other purposes, and I've gone through this in some other videos, but you're able to compare So let's say I have a customer table that has 100 rows in it before the ETL, and after the ETL finishes, it has 150, right? Well, I can compare to see what those 50 were that were added just by comparing the two databases together. And that's really kind of cool, right? Well, let's say you just need to go back to the 100 customers that originally were there. Well, you could just delete the table and then copy those 100 from the original 100 from the snapshot back to your data. And so you can manipulate the data that way without having to do a full restore of the snapshot. Okay, setting the database recovery model to full recovery is another way you can do this. What that does is you're going to have a transaction log that is established for your database, and it's not, and it will keep on every time you do anything in that database. That transaction log will continue to grow until you back it up, and then it will shrink down a bit. But so there's a whole lot of maintenance involved with that, of keeping a transaction log and backing up and everything else, so it doesn't grow to be too big. But in this case, if you need to recover and you have a transaction log and you have enterprise edition of SQL Server, you're able to do point-in-time restores. I believe it started in 2008 version of SQL Server, but a point in time. So as long as you keep track of the time that you started your process, and if things go all haywire, you should be able to go back to that point in time and restore back to that. And there's a whole lot of different knowledge you should have about those restores. It's not a simple situation. You really got to know what you're doing there. So I find it very inconvenient and a lot of overhead. So the drawbacks here: restores all the database in the database to a point in time, which is good. It's to a point in time, but it's bad because it might be overwriting other people's data. If it's not, it's still a hassle to do it. You need Enterprise Edition to do point in time recovery. If you're using Standard Edition, you have to make a full backup at the start of the ETL right at that point in time, and then you restore that full backup. Transaction logs need to be backed up regularly, which is a lot of maintenance, especially. And then also, having a big transaction log, if you're doing it for everything when things you don't even need it for, it's a performance hit usually on your processes on time. I usually set my my recovery model for the database whenever it's a data warehouse, or whether it's staging, or any one of my data warehouse. I set them to full simple recovery, so the process is usually faster, and then because I don't need all that transaction, I don't need everything to be stored as a transaction for rollback capabilities. Metadata process ID status flag. Let me first say that most companies I've ever worked at with ETL already have a process type table. And that process type table usually has something like a batch ID, a process ID. And what it does is it keeps track of all the tasks or each pieces of this ETL, so that you have like a start time and an end time. Okay? And you can use, and I always implement this table also, so that you can track when it doesn't have an end time. Something went wrong. Okay, if last resort, you should have some other error handling capability besides that. But that's one way to check to see. And also it establishes how long things are taken, so you can check for that. For performance anomalies. So there's another part that you could add to this process table called a status flag. And the status flag is basically, you don't actually have to have a status flag. You could use your end date time, that if it's still null, it means it didn't finish. Okay? And I saw this at a very large bank, and they had a very short window, ETL window, and they had to do this like millions and millions and millions of rows of data. They had to insert every night. And what they did was that they used this technique. So what would happen is that when they push the row in to the table, let's say they put in 300 million rows a night, and then with that they would also add the process ID. That's a unique, that would then go back to the process ID table, the process table, and if that table status was not set to true, which means it didn't finish this process, meaning there's an error, then those rows weren't considered. Okay, because what would happen is that, let's say had 300 million rows and inserted, and all of a sudden an error occurred. Well, their window, they couldn't go ahead and they could fix the error and then run another, reinsert all these rows, but they couldn't do the rollback, because if anyone knows how rollbacks work, many times a rollback from a transaction log can take a very long time, and if they did that, they'd lose their window of opportunity to bring the data in for the night. So this is how they did it. So basically they used their process table in a way to determine what the status was for those inserts and whether they were going to be valid rows or not valid rows, and that worked really well for that scenario. For updates, that's going to get a little bit more dicey to be able to figure that out, because you're not going to be able to move them back, or you can't just, an update, you just can't say, okay, the status is false, we're not going to consider that row. Well, that row still has value. So that doesn't work as well. So it works really well for parts of your ETL that have really large numbers of inserts and maybe soft deletes, meaning a soft delete is obviously like a column that has a delete flag in it, and so you don't actually go in and delete the row. For these kind of things, this metadata process ID status flag can be a very good partial option. Okay, so I'll just go through it. The benefits are it's great for inserts, or large inserts, I should say, really big inserts. It's okay for soft deletes. There's no rollback time required for the inserts, so because you're not going to ever do a rollback. Or you might go clean up the data once a month or once a week on the weekend when there's more window of time for your processes. You can leave the database as a simple recovery model. You don't have to have a transaction log, which is really good. But the drawbacks are you might have to manually code, do some coding if you to get rid of your soft deletes and get those back. Probably an update statement. So that does take some time. Updates will not be able to be recovered properly. So it's not going to really take care of your updates when you do updates. So if you have updates, this probably isn't a good solution for that particular area of your ETL. Downstream code will always have to evaluate the process ID status. So let's say you have reports that are querying the database in that sales transaction table. There's a hunk of rows in there that never have that status never was set to true. So in your code that you write for your reports, you have to, in your where clause, say only take the records where status equals true for the process table. So yeah, you got to do that. You got to add that bit of complexity to your code. Not much, but it's still something. And it's probably, if you have a lot of reports, a lot of queries, you always got to remember to put that in. Downstream code will always have to, okay, and I just mentioned that. So that's the benefits and drawbacks. I do like this technique, but not for updates at all. Okay, change data capture. This really isn't a very formal way of doing things, but it could probably work pretty well. It could work. The benefits is probably easy to implement. It's available in Enterprise SQL Server since 2008. It's available in Standard SQL Server since 2016 SP1. You can leave the database in a simple recovery model. Drawbacks. All change history is captured, increasing the size of the database. Now, the change history is captured on just the tables you selected, which is a good thing. So that could be kind of a good thing, and there's a drawback and there's a benefit. The benefit is you can select exactly the tables you want to do it with, and the drawback is you're always collecting data for it. Every piece of change to each of those rows that changes. Could be overkill for recovery of one process. Although change data is captured, it might require large manual effort to go get the data that was before, that was a good data, and restore it back. So you probably have to do some coding to get that ready. You can maybe, it's going to take some workarounds to get that working in code, but it might work for you. Back to how it was before the ETL started and not automatic. So yeah, those are the benefits and the drawbacks. This might be a good solution in some cases, but you better know how to do some coding and understand your change data capture data. Okay, SQL task calling one top-level transaction-ready store procedure. I have used this technique a lot, and I like it, and I don't like it. And the reason why I like it is just what the benefits say. It's a TSQL solution. I like that a lot. I have a lot of control over the code. I can read it. I can maintain it easy. I have a good warm fuzzy feeling when I use TSQL. I can set the TSQL to automatically roll back if there's an error, so I don't have to worry about backups or anything like that. I can leave database in a simple recovery model, so I don't have to have transaction backups for this. The drawbacks in this scenario is your stored procedures could be very long, and if they're not very long, you might have to end up calling out to other stored procedures. So you have this tree of stored procedures. You have one parent stored procedure that calls 5 other stored procedures within it, and then those call some other procedures, so it goes on and on. But what all you see in the graphical user interface of the SSIS is this one execute SQL task. So it doesn't give you that GUI view, a good overview of what's happening in that code or what's happening as far as a process is concerned. That I don't like about it. So I like it as far as a transactional and its cleanup after itself and all that stuff. I really like that. But what this does when I call one single store procedure, I lose the overall self-documenting GUI effect of being able to lay it out, so I can see what's happening from the perspective of the SSIS package. Okay, we finally come to my favorite technique, and that is embedding SQL tasks loaded with TSQL transaction code around the control flow tasks. The benefits of this is that it's TSQL. It's automatically will roll back on an error. That's in the code in the package. Both TSQL and data flows where the insert or update or delete is going into a SQL table and across one or more databases on the same SQL server. You can leave the database in as a simple recovery model. It's intuitive and easy to set up. It only requires 3 SQL tasks for the basic setup and that to get the transaction going. And you also have to set the connection that you're working on, its property retains same connection to true. Again, in the last area I said to you, when you do the transaction, you could have instead of calling one store procedure and having that store procedure call all these other store procedures and a cascading effect that only occurs in that one store procedure, you can break those store procedures out and have them each have their own execute SQL task labeled, so you can see how the flow works in the data. Even though you're using SQL Server store procedures, you'll break up your store procedures into these objects, so you can just see the flow and the logic and the route, how it routes the data flows and routes through these different procedures. Drawbacks: it may be used in coordination with other databases, or it may not be used in coordination with other databases like Oracle, and it may not be used for distributed transactions across different SQL servers. So what we're going to do now is go ahead and do an example to show you how this works and why it's my favorite. Okay, let's look at our example here. I've already set it up. So first of all, let's just go ahead and take a look at our database. I have 3 databases I'm using here. I have AdventureWorks 2014. I have Test ODS and Test EDW. I kept it very simple. So basically, I have created a table in ODS called ODS Customer, and it has plenty of columns, and it mimics the same as the DIM customer over in the AdventureWorks 2014 up here. Okay, about 18,000 rows there in this database. Okay, in EDW, I condensed the table into 4 columns and called the EDW customer. First name, middle name, last name, yearly income. Okay, so basically I moved data from AdventureWorks using a data flow into the Test ODS ODS customer. 18,000 rows will go in there. And from here, I'm going to move 50 rows into EDW customer. Those 50 customers, I'm going to give a yearly earnings income. I'm going to make it 200,000 because I'm a nice guy. And then after that, we're going to delete 10 of them because I'm not a nice guy. So there's only going to be 40 left. And then we're going to cause some errors. So let's look at the package. So the key to the package here is to begin your transaction outside of the data that you're going to manipulate. And inside here, if there's an error, it should go out to the rollback to roll back the data. If it doesn't cause an error in here, all these data manipulations will be committed, and we should see data. Okay, so the important things to remember here when you're doing this transaction, we are doing 2 different tables and 2 different databases. So the question really is, what in the begin transaction, what data connection should we set it to? Well, we could set it to either one. Okay, we can set it to EDW or ODS. AdventureWorks, we're just reading out of there, so really it doesn't matter there. But it has to be one of these 2. So when you choose, it doesn't matter which one you choose, but once you choose it, you need to set up all your connections for the SQL to that same connection. So begin transaction is test ODS. We go to this SQL command, and we have test ODS, even though I'm inserting into the EDW customer table. Okay, then I update the yearly income of the EDW customer table, and again I still leave my connection to test ODS. Of course, then I have to put the 3-part naming convention in here, so I have to put the database.schema.table name. Okay, and so that's what that looks like. So here is where I give them the big yearly income, and then here I delete out of those 50 I put in here. So if you look at the 50, I insert 50 rows out of the test ODS. I put them into the test EDW. Okay. Okay. Then at the end here, I delete 10. So here's my deletion of 10 of the EDW. But again, you got to remember, I have the test ODS. If you don't keep the same connection that you set up the transaction on here, it will hang and you'll be blocked. Okay, so you have to make sure you have to make sure your connections are all the same as what your begin transaction, rollback, and commit are. Okay, and then here I do a divide by 0 and cause an error. So I select 1 over 0, column 1, and that will raise an error. So that sequence container here will then go to the failed error routing, and it will come into the SQL and it will roll back. Again, test ODS, and then just the rollback command. And then here's a SQL commit. If everything works well, it comes and does test ODS and commits. But that commit, and same with the rollback, will affect the EDW because it's all within that same process. Okay, so that's an important thing to remember, okay, because first when I set it up with EDW in some of these for the connection, and it would just hang. All right, so you have to set it up the same as what your transaction is set for, and use your three-part naming conventions. Another thing you have to do is on your connection string, if I right-click on the connection string, you have to, the default for retain same connection is false. You need to set that to true. And I set it to true for both of the databases where I'm updating tables or inserting tables, okay, or deleting tables. All right, so all those things have to be in order, okay. So let's just see what happens when I run this, okay. So right now it's going to divide by 0. Let's look at what data is in there to begin with. So I'm going to select from both those tables, and as we see, we have data there. So let's truncate that data. Execute. Now we're going to, so we cleaned up the data. There's nothing in there. There's nothing in either table. Okay, so this is going to try to do its inserting and updating and deleting and all that stuff, but it's going to run into a divide by 0 error, and it should roll it back, and we should still, after we finish this whole routine, once it hits that failure and rolls back, we shouldn't have any data. We'll check that. So let's right click on it and execute package. Begins the transaction. It hits the error. It does the data flow here. 18,000 rows were pushed. It succeeded on these different SQL commands. And these could also be call outs to store procedures. And then it hits the divide by 0. And notice when it hits the divide by 0, it goes to the failure route and it goes and does a rollback. All right. So this should have rolled back all the changes. So let's go over to SQL Server and run our select again, and we should not see any rows here. And as you see, we see no rows, okay? So now let's go back to that same example. And this time I'm going to disable the divide by 0 error, so we'll never hit that. So all these will succeed, and it should go to commit, and we should see all our data then. So I execute the SSIS package. And it rolls through everything. Everything works. Okay, so now we're going to go, let's look at the data flow here. 18,000 rows. So we should see 18,000 rows in the ODS customer, 50 rows in the EDW customer. Then we updated all their yearly income to 200K, and then we deleted 10 of them. So we should see 40 in the EDW customer, 40 rows with 200K for their yearly income, and in our ODS we should see 18,000 and some rows. So let's go over and see what we got. So I'm going to run this. So my EDW is my first result. You see these are all 200,000 like we thought, like we updated. And notice we have 40 rows, which is exactly what we thought. Now here's our second table, which is the ODS customer. And as you see from down here, it's 18,484 rows, which is correct. And you'll notice also that their incomes were not 200,000. They were all over the place, as in here. I don't know if there's any 200,000s in there. Okay, so anyways, that's how it works in a nutshell, in a very simplistic simplistic model and example, and this is why I really like it. And I don't have to hide all these different parts of my SQL into one big stored proc. I can just go ahead and do it all separately, so I can graphically and visually see the flow of how it flows. So let's see what happens if I change the connection back to if we change the connection to false and run this, and let's see what happens then. I'm going to go ahead and truncate my data. And I'm going to then run. So I've set the main where they set the transactions to not retain the connection. And notice when it tried to do the commit, it failed. So let's look at that error message. Commit failed. The commit transaction request has no corresponding begin transaction. It doesn't have a begin transaction because each one of those SQL tasks were done as a separate connection. So that's why you need to keep the retain connection set to true so that it recognizes the whole transaction throughout the entire spectrum of the package, all the way from the begin transaction to the commit or rollback. And that's it. So thanks a lot for listening, and I hope you got a lot out of this.